Hey everybody, Mr. Piercy here. What we're going to be talking about in this lesson is kind of the conclusion of a reasoning unit. So we started off in reasoning talking about inductive reasoning, which is based on a pattern that you observe, and from that observation you then write a statement called a conjecture that you can use to maybe write an algebraic rule for or use to make a prediction of some kind. Then we started talking about different kinds of conditional statements. Remember, a conditional statement comes in an if-then form. You know, we have the converse, inverse, and contrapositive of those statements. From the converse and the conditional statement, we could determine if we could write a biconditional statement, which could be used to write a definition of something. And then we got into deductive reasoning, which is based on statements, not patterns. Well, from deductive reasoning, we're getting into something known as a proof. Now, a proof is a chain of statements, really. I'm not going to read the entire thing for you. You can read it for yourselves. But a proof is a chain of statements that we use to justify something. I want to be clear that a proof is a presentation tool, not a solution method. Okay, we're not trying to show why something is the way it is. It's a justification tool. It's just a way of, in a proof, we know what the outcome is supposed to be. It's not so much that we have to set up and solve an equation necessarily, but we generally know what a proof is, or what the conclusion in a proof is. At least in a geometric proof, I should say. So what we're going to be practicing is we're going to figure out ways to assemble those statements so that way we can justify why the conclusion is correct. Now, in algebra, you have seen a fair amount of things that are related to I don't know how they justify when you do a step in math. These and this one here, these are kind of algebraic reasons for what we're going to be doing something. Now, first of all, everything in this table is what we would refer to as a reason of some kind. Now, here, let me pick a different color. What these are pretty much limited to geometric stuff. Now, the transitive property, this last one here, the transitive property, that is something that really can be used outside of geometry. But these three statements, these three highlighted here, those are very much geometric properties that we use as a reason to make a statement in a proof. Now, we're not going to be coming back to this, or we're not going to be using this table here immediately for everything, but it is something that I want to make sure that you know where it is because you will be referring to it fairly regularly when you're trying to do a proof. And I'll probably be providing some additional information besides this to say, hey, these are a whole bunch of reasons that get used in geometric proofs, not just the things that you see here on this table. Now, the addition property, subtraction property, basically those are things that we would use to say, well, when I move something across an equal sign in a math problem through addition or subtraction. Same thing with multiplication or division. We're multiplying something across both sides of an equal sign or dividing something on both sides of an equal sign for whatever we're trying to solve. And at the bottom, when it says the substitution property, well, that's basically we've been using it in geometry, but it's also something you use in algebra where you say, well, I can substitute this value for x, or I can substitute this expression for the length of a segment, or something along those lines. So let me explain to you what the reflexive property is. The reflexive property is essentially saying that we have something that's shared. So here is a, I don't know, a quadrilateral with a triangle. So let's say this is A, B, C, D, and E. Those are the vertices. Well, here I can say that BD, segment BD in the quadrilateral, must be congruent to segment BD of the triangle, and I'll say quadrilateral here and triangle here, because they're shared between the two. So obviously if it's the same thing in both figures, it has to be congruent to itself, or equal to itself if you're actually giving a number. The symmetric property of either equality or congruence, depending on what symbol is used, is basically saying, well, if this number is, oops, go away, notification. If this number is equal to, or if this thing is equal to this thing, then I can just turn it around. It's, it's almost like you're just drawing a line of symmetry down through it and saying, oh yeah, it's like a mirror image. So the transitive property is very similar to what we refer to, or what we practice with the law of syllogism. The law of syllogism said we have these two conditional statements. If the conclusion of one of the statements and the hypothesis of the other one match, then we can more or less eliminate them and take the hypothesis of the first one and the conclusion of the second one and make a new statement. And that's exactly what we're seeing here with the B and the B. That is very much saying, well, the conclusion of one statement and the hypothesis of the other statement are the same, which allows me to take this hypothesis and this conclusion to form this new statement. So that's what the transitive property is saying. Now here, this last one, the distributive property, this is purely an algebraic reason for things that you would be doing where you're literally just kind of moving things into the parenthesis through multiplication. Okay, so moving on, now we're going to take a look at how we're going to use some of those reasons to justify an algebraic step. And many of you that have already seen Algebra 1, you've probably practiced this at some point when you were really practicing how you solve multi-step equations. Well, what's the reason? How are you doing it? Okay, so here we're taking a geometric figure. We have a linear pair of angles. And so what we're going to say is that angle AOM and angle MOC are supplementary. And the reason why is because they form a linear pair. So moving on, we can say angle AOM and angle MOC have to have a sum of 180 degrees. The reason why is because that's the definition of supplementary. All right. Now, so far what we've seen as far as the first two steps, we've practiced that with angle addition, where we would take an angle and another angle and make it equal to something else. And then the substitution of the algebraic expressions for the angles is what we did next. And that's really what our reason for the 2x plus 30 plus x equals 180 step comes from. Now then we combine our like terms, and that's what we generally think of as simplification. Then the next step would be to move the 30 from the left side of the equation to the right side of the equation. And because you have to subtract the 30, that's the subtraction property of equality. All of these here really should say equality at the end because it actually uses an equal sign. I just got a little lazy when I typed it up and I didn't actually write equality or type equality on here. So lastly, the last thing that we would do at the 3x is equal to 150 mark is we would divide both sides by 3 to isolate our variable. And because we're dividing, well, that means we're using the division property of equality. So those are the steps that we take when we set up and solve an equation, and on the right side are the justifications, or the statements. Why are we doing this? This is a reason. So here, at this point, what I want you to try and do is pause the video and see if you can come up with your statements and reasons for what we're doing here based on the information that's given to you in the diagram. So go ahead and try doing doing this problem on your own, and when you're ready, come back and check to see what I said. All right, so I'm going to presume again that you've done what I've asked you to do, and we're going to start in this case by saying that angle RAB is congruent to angle NAB because that's the definition of an angle bisector. And the reason I start that way is because it says ray AB bisects angle RAN. So that's really what allows me to make that statement. So now if I can make that statement, the next thing I can do is use the substitution property to substitute the expressions in for those particular angles. Then in this case I would actually move the 2x to the left side of the equal sign, so that way I could isolate the variable. And then here I really could either multiply or divide. Here I just said divide with a -1, but you could also said multiply with a -1 because the coefficient of x is -1, so we wind up with x to be equal to 75. And that is all of the steps and the justifications that I was able to come up with for this example. Now here, what we're going to be taking a look at are a little bit more of, we have the same words. We have the reflexive property, the symmetric property, and the transitive property. Those we saw in the table earlier. Now the key difference really between this table and the one that we saw a second ago, and let me pick, here, let me just, I don't think I want to use a highlighter here. Let me just circle it, is this word right here. On the previous table, it said properties of equality. This table is talking about properties of congruence. And the difference is that if we were saying properties of equality, well, if we're talking about properties of equality, then that means I am using the equal to sign. If I'm talking about a property of congruence, then I will be using the congruent symbol. That's the difference between what we saw in the reflexive, symmetric, and transitive properties before and what we're seeing now. All right. So what I would like you to do, again, I want you to go ahead and try this one independently, and then I will show you what the answers are. But in the 4 examples at the bottom, A, B, C, and D, there's some kind of property being displayed. And the purpose of this exercise is simply for you to be able to look at the either algebraic statements or the geometric statements and determine, well, which property is being displayed. So go ahead and pause the video now and try and figure out what statements go with which problems. And when you're done, push play again and check to see how you did. Okay, so now that you've had an opportunity to answer the questions yourselves, let's take a look at A. Well, here we say 2x minus 9 is equal to 19, and then in the next step it becomes 2x is equal to 28. Well, clearly we moved the 9 over from the left side of the equal sign to the right side of the equal sign through addition. So that's the addition property of equality. And again, because it uses an equal sign there, that's why I say equality, particularly at the end. So now here, angle O is congruent to angle W, and angle W is congruent to angle L. So that means I can say angle O must be congruent to angle L. Well, that's very much the transitive property. In this case, we're going to say the transitive property of congruence because of the symbol that was used. Part C, the measure of angle E is equal to the measure of angle T, and the measure of angle T is equal to the measure of angle E. Well, you can see all we did was just flip those around. So that is the symmetric property, but because of the symbol that's used, that's the symmetric property of equality. Now the same thing with D. Here all we really did was reverse the statement, but because of the symbol that was used, we would call this one the symmetric property of congruence. All right, so we're going to go ahead and pause this video for now, or pause this lesson. There is still more to come, but I don't want to make this too long. So at this point, I'm going to go ahead and pause, and we'll continue the remaining lesson in the second video. But as always, ladies and gentlemen, if you have questions, make sure you write them down in your notes and email them to me or leave them to me as a comment in the section or in the comment section of our Google Classroom, and I'll be happy to discuss them with you. But until you get to the next video, guys, thanks for watching, take care, and we'll see you soon.